give you two examples of some issues that I've come across in two of my cyclone studies and how we fixed them with GIS and what the issues were. So this is based on my landfalling tropical cyclone study for New South Wales, and the focus was to make a database of landfalling tropical cyclones for New South Wales. One of the issues we had was this is Tropical Cyclone Nancy, and it did a lot of damage around the Byron Bay area. However, when we initially filtered our tropical cyclones using from the Bureau database, it wasn't actually included, and we had this big conflicting issue between our track data and then our report data. So we had to try and figure out whether we were going to include this track or whether we were going to omit it like it was in the original database. So our compromise was that we actually used a buffer. So we used a 0.5 kilometre buffer, which if you've done any buffer work, that's pretty negligible in relation to tropical cyclone size. Usually they're about 500 kilometres max. And we included this buffer into the study just so we could include this tropical cyclone track. The other consideration that we had for this cyclone track is that the track in GIS doesn't actually represent the size of the storm. So yes, the cyclone probably did make landfall between Brisbane across Byron Bay, but it's not represented with a line. So that's how we fixed that issue. The second issue was from my study that I talked about this morning. So one of the issues we were having is that when we were cross-validating and pairing the NSET1 data and the matches data had 5 tracks to one NSET1 track, and we couldn't figure out why. So to fix it, we put all the track data into GIS to have a look what was actually going on. And panel A, you will see that the matches data actually had 5 tracks that were 1 track in NSET1. So we had to go through and we had to manually check and merge all of the matches tracks that corresponded to one NSET track. And that was our process. You can see throughout the different panels. So, and we did it and it worked and it was a long process. And then this one's just the fun one. So again, this is showing the superiority of the NSET1 database. So we had this matches track that paired with 2 NSET tracks. So it was a reverse, and we couldn't figure out what was going on. Again, we put the track data back into ArcGIS to see how it looked spatially, and this matches track has jumped from the start of one NSET1 track to the end of the other one. So I just got a video. So we had to look at the mean sea level pressure charts from the Bureau to actually distinguish what was going on. It's probably easier, yeah. So you've got these 2 here, which essentially line up to the 2 tracks from the NSET1 database. So the quick fix for this was that we unpaired the matches database with the second NSET1 track and kept it with the other one. It wasn't as accurate as it probably should have been, but because the mean sea level pressure chart showed how the 2 trough systems were working and the frontal system off the side, it was that issue. And that was it. Thank you for listening.